So we are solving differential equations as we continue this lesson today. If you go back to example 1, which was yesterday, we explored the differential equation dy dx equals 3x squared. And if you recall, that was derivative of all of the x cubed functions, right? X cubed plus a constant. So differential equation is just a statement about the derivative of y with respect to x. We found a family of functions that had the same derivative. This antiderivative is the general solution. Now, our goal is to solve for y with a specific solution for the constant of integration plus c, based on an initial condition that can be used to find c. So basically, yes, we are taking the antiderivative, okay, or the integral. But then once we get that, remember, it's going to have a plus c. So we're going to be plugging those values in to finding c. Hi, Jerry. I get that, you get that, you've got that and that. I think we're good. Okay, so solve the differential equations subject to given conditions. With this in mind, we know the derivative, yes? And I'm going to show, to make this appropriate form, I'm going to show a little bit of notation here. So another name for f prime of x is, we could say, dy dx, correct? And again, I'm just showing you the official notation, okay, and what all goes together. Now, before we do any antiderivatives, we have to know with what variable we're doing the antiderivative with respect to. Well, right now, my dy and dx, I have x and y on the same side. So dy dx is a fraction. So how do we get this dx over to the right side with the other x's? You multiply it over. Okay, so I know we generally think of it as an expression that means derivative, but you can multiply it over. So I'm going to rewrite this as dy equals 2x minus 1, the quantity of, times dx. And the reason I did this is that puts us in an appropriate form here, because now we know dy, our job is to find y. We need to take, as you guys were talking about before I ever started, the integral, the antiderivative. So I'm going to put my little integral signs. The integral of dy, just y, right? Because think of this, you're integrating the number 1. What's the integral or the antiderivative of 1? And that is y. Over here, integral of 2x minus 1. So what's the integral of 2x?
X squared.
X squared. What's the integral of minus 1? Minus x. What can you not forget? Plus c. So this right here with the plus c is what we will officially call our general solution. Okay? So when you're asked to find the general solution, a general solution allows you to have a plus c on it still. Now, it, however, asked us to solve subject to the given conditions. What else were we made aware of? F of 2 equals 5. So keep in mind there that 2 is an x value and 5 is a y value. By plugging in those values for x and y, we can now find c, and we will have our specific or particular solution. So if I basically plug in the ordered pair 2, 5, 5 equals 2 squared minus 2 plus c. If I did my math right, c is 3. Yes? Sure, I kind of kept working, and
Yeah.
I assume you guys were okay on your own. I quit talking and kept working. So now we have the information to write our specific, okay, so up top it says specific solution. I have it noted as particular solution. Interchangeable vocabulary. Be familiar with both, okay? So whether we talk specific solution or, I'm going to throw it here so you have it in writing too, particular solution, and I don't remember what homework asked for. That could be why I said particular, who knows?
Yeah.
Does it ask for a particular solution? So that's why I threw this in. So, particular solution, take your general solution, fill C in. So, y equals x squared minus x plus 3. Oh, okay, I wrote y. My notes actually say f of x. They probably say f of x because we originally started with f prime of x. So, it says f of x. It's all equivalent, right? At this level in the game, I don't feel like Okay, shall we try a few others? Okay, so B. I'm going to show similar notation. F prime of x is another way to say the derivative of y with respect to x is equal to 2 cosine x. Official notation. I can't really integrate if I don't have the piece telling me which variable to integrate with respect to. So multiply the dx over. dy equals 2 cosine x dx. And now you're ready to take the antiderivative. Of course, on the left, integral of dy, or of 1, I should say, is y. Integral of 2 cosine x. So, can we all agree there's a 2? And we can all agree there's a sine x, yes? Because the constant 2 just stays. It's technically, you can pull that constant out front and really just carry the 2 down. We're integrating cosine x. And then my brain goes, I check with derivatives. I work backwards. The derivative of sine is cosine, so that makes sense. And then plus c. Okay? So that is my general solution. And then in order to find the specific solution or particular solution, this time I'm using the ordered pair pi over 2 comma negative 3. So y equals negative 3 equals 2 times the sine of pi over 2 plus c. What is the sine of pi over 2? 1. So negative 3 equals 2 plus c. Subtract 2. C is negative 5.
These are kind of fun. Since they know how to push.
I say, as long as they're easy, they're not bad, right?
No.
Okay, your particular or specific solution. We had y equals. This time I'm going to write it as f of x equals. It was 2 sine x plus c. So 2 sine x minus 5. Okay. I don't feel like we have any, I don't know, maybe I'm missing them, but I don't feel like we have any horrible difficult ones on this page. I mean, you have to work a little bit. I'm going to challenge you to not get the calculators out. I know the temptation. So, okay, C. You know the starting. dy dx is x squared plus x minus 7. So, whoops. dy is x squared plus x minus 7 times dx. And we're integrating. Integral of 1 is y. Okay, we've slept since yesterday. Integral of x squared.
1/3 x cubed.
Okay, so, and here's the deal. I tend to write mine as 1/3 x cubed. However, I can almost guarantee if you look in the answer key, it's going to be written as x cubed over 3. It's a personal preference, totally. Okay? So, but you add 1 to the power and you're dividing by the new power, right? So you're dividing by 3. Okay, plus antiderivative of x. Add 1 to the power, divide by the new power. So Doug said 1/2 x squared. You can also write it as x squared over 2. This is where I say you do you. Okay? Minus antiderivative of 7. 7x, where technically you're adding 1 to a 0. So it's x the first, you divide by 1, it just stays 7. And then plus c. That, of course, is our general. And now, yeah, we are inputting 3, 1. 1 equals 1/3 times 3 cubed plus 1/2 times 3 squared minus 7 times 3 plus c. This is where I said the challenge is to not dig for the calculator, right? Okay, so I got 1. 3 cubed, 27. Divide by the 3, 9. 3 squared, 9. Divide by the 2, 9/2. Minus 21 plus c. Okay. Somehow or another, you got to do the math here. You could go all halves, or you could make that 9/2 4.5 and think that way. If I go halves, what is it? 18/2 plus 9/2 minus 42/2. 18 and 9 is 27. 27 minus 42. Well, here's my 42 minus 27 math, which is 15. Since it was 27 minus 42, it's going to be negative 15/2.
Yeah, you got it.
If we're adding 15/2 to the other side, we're adding it to 2/2. So C is going to be 17/2,
Yes, I got it right.
which
8.5.
I would say 8.5. Yeah, I was just doing the mental math there. Okay. F of x equals, wrong piece. Where's my equation? There we go. 1/3 x cubed, 1/2 x squared, minus 7x plus 17/2. See, there's your challenge. Don't grab for the calculator.
That's real challenge.
I know. And that's why part of the reason we started the year off with little calculator usage is this, right? Okay. Okay, moving on. dy dx is 3x squared minus 4x plus 2. So if I multiply my dx over, dy is 3x squared minus 4x plus 2 times dx. And I'm ready to integrate. Are you guys ahead of me, I'm guessing?
Is it x cubed?
X cubed minus 2x squared plus
Yeah.
2x plus 6.
So x cubed, add 1 to the power, which makes it 3. And when you divide by 3, what do we already have, though? A 3, yes? So when you divide by 3, it's canceling. Minus, okay, add 1 to the power, it's x squared. When you divide by that new power of 2, 4 divided by 2 makes it 2. Antiderivative of 2 is 2x plus c. Are you guys getting better at that? You haven't even done homework yet? Which I don't think the homework key's open now that I think about it.
No, it's not.
Okay, sorry. Remind me when I get done with notes. Okay, ordered pair of -1, -4. -4 equals -1 cubed minus 2 times -1 squared plus 2 times -1 plus c. Well, at least we don't have to go the fraction route this time, right? -4. -1 cubed is -1. -1 squared is 1 times the -2. 2 times -1 is -2 plus c. -1 minus 2 minus 2 is -5.
Yeah.
And so when I add 5 over, c is 1.
Yes.
Yes, seriously. It's easy.
So f of x equals x cubed minus 2x squared plus 2x plus c, which is plus 1. Okay.
They changed the colors on the name.
E. G prime of t.
What do we DGDT?
Or dy dt.
DYDT.
Yeah. Officially, so we still use y because it's just like g of t, f of x. You still use y in place of that. But officially, this would be dg dt because the variable, the independent variable is t instead of x. And then what's another way to write square root of t that we might as well do now? T to the 1/2. Or wait till later. I don't care, but you're going to need that thought at some point, aren't you? So then dg is equal to t to the 1/2 dt. Oh, I said I wasn't doing GD. My goodness. Guys, don't let me do that. I just said it wouldn't be dg dt, it would be dy dt. What did Mario say?
He wasn't going to say anything. He was just letting you do your own thing.
Whatever, let me do my own thing. It's just whenever I figure it out, I'm going to be annoyed. So yeah, it's not, you can think of it. When it's f of x, do we use df? No, f of x is another name for y. Now, could you say dg? You could. Okay. Okay. Integral of dy. 1y. Integral of t to the 1/2.
2/3 x to the 3/2. X or t.
Get it.
Okay. 2/3 t to the 3/2. Adding 1 to the power makes it 3/2. Now, officially it's dividing by 3/2. But dividing by 3/2 is multiplying by 2/3. And, you want to save yourself the step, right? You can write it as divide by 2/3 and then fix it the next step, but
Is it 9 cubed in the square root of 2, or am I wrong?
hold on. 9, 6, let me get there. 6 equals 2/3 times 9 to the 3/2 plus c. Okay, so this is 2/3. So the 9, the 2 is the denominator, so it's a square root of 2, or square root of 9 raised to the 3rd.
Okay.
Now remember with that, You can do 9 cubed first if you want and then square root it. That's going to make me dig for my calculator.
Yeah.
Okay.
I can do the square root of 9 and get 3, and then I know 3 cubed is 27. That's easier for my brain without digging for the calculator. So then we have what? Oh, 2/3 times 27. So 2 times 27 is 54. So I have 6 equals 54 thirds plus C. Well, if I make 6 in terms of thirds, it's going to be 18 thirds minus 54 thirds. Well, it's going to be negative of whatever 54 minus 18 is. Negative 36 thirds. So negative 12. My answer key agrees. That's always the check, right? Although I didn't hear any of you guys yelling at me, so. G of t is 2/3 t to the 3/2 minus 12. Okay. And F. I do actually have one written in here. I don't remember why. I have one from homework I want to do together. Oh, because they kind of change things up and they give you something in homework that you haven't seen in notes. So that's why we're going to do one of the homework questions. Exactly. Not surprised. Okay. F prime of theta equals sine theta. So I'm going to call this dy d theta equals sine theta. Oh, go figure. Guess what I did in my notes? df d theta. I can't win for losing here. Do whatever you want. Okay. So, dy equals sine theta d theta. We're going to integrate. I'll catch up with all you guys eventually. Y equals the integral of sine. I think so.
Yeah.
Because the derivative of cosine is negative sine. But since I don't have the negative here, I need to put my negative on the cosine. So the derivative of cosine is negative sine, but it's a negative of the negative, which makes it positive. Okay, plugging in 0, 2. So 2 equals negative cosine of 0 plus c. Cosine of 0 is 1, but it's the negative of that, so negative 1. And then when you add the 1 over, we have 3. So f of theta is negative cosine theta plus c.
Plus 3.
Okay, I wrote plus 3. I said plus c, didn't I?
I didn't look up plus.
Okay. And I have written in my notes, homework number 17 is where I want to go.
They have a double derivative.
Exactly. Have we done anything with that?
Oh,
No,
18
what
is
is
the same.
17, 18, 19, 20.
Exactly. So if I do 17,
Yeah,
I'm prepping you for
that was good.
18, 19, 20.
I think I can do it.
Are you alright there? There you go.
Okay, now, the problem I have, I don't have 17 on a screen. So, I'm going to pick a screen and put 17 on here. So, bear with me for a moment. Homework number 17. What do we know? F double prime of x is 4. F prime of 3
2x.
is 7.
X.
F3 is negative 1. Did I get it all?
2x squared.
Okay, so yes, this is not in the notes, so I have written here, not in notes, do as part of notes. So that's why we are here. Okay, guys, we are starting with this piece of information right here. Okay, f double prime of x is equal to 4. Now,
Shoot.
if we move up in relation to this, f prime of x is going to be equivalent to the what of 4? If we're going from second derivative to first derivative, it's going to be, hold that thought, the integral of 4, yes? Okay, so this is what I'm trying to get your brains to think here, is that you're going to be integrating, in order to find the first derivative, you're going to be integrating the second derivative, yes? Now, what Mario was saying, what is the integral of 4? So my first derivative is going to be equal to 4x plus c, yes?
Yeah.
Okay, now, because of what lies ahead, I'm going to call this C1, okay? Just because, as you can tell by me saying C1, we're going to have multiple C's within this problem.
Then just
Not all at the same time.
just
okay.
end up being. Sorry
Okay,
if I
so
went
now-
too far.
How do we find C1? F prime of 3 equals 7, yes? So if F prime of 3 equals 7, you're essentially plugging in the ordered pair 3, 7, yes? So we're going to know that 7 equals 4 times 3 plus C1. So we're going to find that C1 is negative 5. Right?
Yes.
If C1 is negative 5, then what do we officially know about f prime of x?
4x minus 1.
Going right here, it was 4x plus C1, so it is now 4x minus 5. Okay, so now we need to find f of x. In order to find f of x, you need to find the integral of f prime of x, which is 4x minus 5 dx. Are you following?
Yeah.
I mean, you probably kind of see where we're going from here. So, f of x, okay, what is the antiderivative of 4x?
2x squared minus 5x.
2x squared minus the antiderivative of 5 is 5x plus c. I'm going to call this one C2 because is this the same as the previous C? Okay, it's not the same as the previous C. That's the only reason. Honestly, do you really have to say C1 and C2? Not for your personal work. So now, we're using the information that f of 3 equals negative 1. So we're using the ordered pair, 3, negative 1. So, negative 1 equals 2 times 3 squared minus 5 times 3 plus C2. Negative 1 is 18 minus 15 plus C2. Negative 1 equals 3 plus C2. C2 is negative 4. So f of x is equal to, right here, 2x squared minus 5x minus 4. Not bad.
Number 18 is
Maybe it falls into the category of kind of fun.
easy.
I don't know. Okay.
It's a position function.
You have some homework to be working on. 6.5. I think it's only 3 pages. It is 28 questions though.
Negative 16.
Okay.
T squared.
And there'll be some of these that we need to talk about on that last page for sure. I will get the answer key posted. You guys get working.